Hello. Now we are going to look at rates of flow. So flow refers to the movement of liquids, and rates tend to mean how things are changing. So what we are referring to really is the speeds of the movement of liquids. So it could be water or it could be oil. So if we take an example here, we're going to imagine we have a water pipe, a cylindrical water pipe, and water flows at 10 centimeters per second. So the particles of water, the H2O, particles are moving, or molecules are moving at 10 centimeters every second. So every second they move 10 centimeters down the pipe. And the pipe's diameter, this circle with a line through it means diameter, is equal to 12 centimeters. So that means the radius is going to be half, that is going to be 6. We want to find the volume of water that passes through the pipe in litres per minute. And we want our answer in terms of pi. Now, to get rates of flow clearly, what we really want to do is try and take a snapshot, or perhaps 2 snapshots in time, and think about this water molecule, this H2O, that's moving through the pipe. So if we imagine that there is a particle of water sitting 10 centimeters back, 10 centimeters back from the end of the pipe. So we take a snapshot in time and the particle of water is 10 centimeters back from the end of the pipe. So it's sitting at that point. If the water is moving at 10 centimeters per second, that means if we take another snapshot a second later, it's going to be right at the end of the pipe. It's just going to be coming out of the pipe. So that's what we can do to imagine our rate of flow, how quickly the water is moving through. And when we do that, perhaps it becomes more obvious how we're going to figure out the volume of water that's passing through the pipe. Because now we can see that we effectively have a cylinder of water that's moving every second. So all of the water that was in the pipe in the first instant, when our particle of water was back here, all of the water in front of that, as well as the particle that we were interested in, have exited the pipe after 1 second. So that means there's a cylinder of water 10 centimeters tall and with a radius of 6 centimeters that has exited the pipe. So now we can see a way to connect the velocity of the water, the speed of the water, to the volume of water that's coming out of the pipe. So we can imagine if it's moving at 10 centimeters per second, all of the water in the last 10 centimeters of the pipe has exited over that 1 second. And if it was moving at 30 centimeters per second, then all of the water in the last 30 centimeters of the pipe would have exited in 1 second. And that would give us the height of a cylinder of water that is moving out of the pipe every second. So can we go from there and turn this into a volume flow rate of litres per minute? And we know that there are 1,000 centimeters cubed in a litre, because a litre is a 10 centimeter by 10 centimeter by 10 centimeter box. So what we want now is now we've figured out we're talking about a cylinder. What we're going to do is write down the volume of a cylinder. This is pi r squared h. We get that from page 10 of our log tables. And this isn't exactly a volume because we're dealing with a snapshot over a second. So really what we're imagining is the volume that goes through per second. So we are really talking about volume per second in this case, because we're dealing with 10 centimeters is going to be the height of our cylinder, but that's per second. So again, we have our diameter given to us is 12 centimeters. So our radius is going to be 12 all over 2. It's going to be 6 centimeters, just to write that down. So we have radius is equal to 6 centimeters. And the height, again, this is per second, is going to be 10 centimeters of water coming out of that pipe. The last 10 centimeters of water in the pipe. So now we can just sub in. And we want to, once we've subbed in, we're going to keep it in terms of pi. So we're going to leave pi in our answer. Going to be 360 pi, and that is currently centimeters cubed per second. So So we've got the volume per second, but we want to turn it into liters per minute. So we need to start converting. So if we wanted to turn that into per minute, well, every second we're getting this much. So in volume per minute, we'd have 60 times that, because every second we're getting our 360 pi through. So that's times 60 to turn it into minutes. Gives us 21600 pi centimeters cubed per minute. And then we want to turn it into liters, so we need to divide by 1000. And we end up with 21.6 pi liters per minute, and that's our final answer, because we're asked for our answer in terms of pi. Now let's put this into practice in terms of a water tank. So if we have an empty house water tank, and we have its dimensions of 2 meters by 80 centimeters by 60 centimeters, and it is filled by a pipe flowing at a rate of 1 liter per minute. So this time we're given liters per minute. How many hours would it take to fill the tank? So there's lots of information here that we need to be careful of. So we're asked for a number of hours, but we're given a flow rate in minutes. And we're given this as 2 meters, but we can see everything else is in centimeters, so we convert that to 200 centimeters. So let's get into what we would need to do. We have a particular volume coming into the tank every minute, and then we have a particular volume we need to fill. So if we figured out the volume as centimeters cubed per hour and then divided it into the volume of the tank, then we would get the amount of time it takes to fill the tank. So let's do that. We need to convert this flow rate, this volume per second, per minute in this case, 1 liter per minute, which means that at volume per second, per hour I should say, volume per hour is what we want to convert to here, is going to be 60 times that. So every minute we get 60 times our, every minute we do 1 liter or so over, or the hour we do 60 of them. And now we need to convert this to centimeters cubed so we can compare it to the volume of the tank. So there's going to be 1000 centimeters cubed here. So we're going to multiply by 1000. So that's how many liters are being loaded into the tank every hour. And now we need to know how big the tank is. So the volume of the tank is going to be it's a rectangular tank. I should have said that. This is a rectangular tank, so that's just going to be length by width by height. And we multiply that out, and the tank itself ends up being 96,000 or 960,000 centimeters and I have this written incorrectly, I apologize. I found my flow rate, I converted from liters, so this is centimeters cubed per hour and centimeters cubed per hour. So I now know my overall volume, and I know how many centimeters cubed are being added per hour. So now to find the time to fill, that's going to be my volume divided by my flow rate. And we write that in. And we get 18 hours to fill our tank. Now, a barrel is emptied at a rate of 3 liters per minute. The barrel's dimensions are 10 centimeters and the height of the barrel is 30 centimeters. At what rate is the water level dropping in centimeters per second? And take pi to the 3.14. In this particular case, I'd really like to draw a picture, so let's draw in a diagram. So we have our barrel of water, our cylinder of water, that should actually say cylindrical barrel of water, and it has a particular water level. The dashed line is where it was, but it's dropping, so it's dropped down to this new level in a particular amount of time. We'll say a second. So it's dropped this height in a second. So if we have that, then how do we find out what this height is that we have dropped by? Well, we know that this volume, that this blue cylinder here, the dashed line down to the solid blue circle, we know that that cylinder of now absent water came from or appeared because of this flow rate out of the barrel, out of the cylinder. So if we can figure out what this is in centimeters cubed per second, then we can work out what that will be the volume of this now absent water, and we'll be able to work out the height of the cylinder. So let's convert our volume per minute. So volume per minute is 3 liters per minute, which means it's going to be 3,000 centimeters cubed per minute. Multiply by 1,000, and then we want it per second, so we divide that by 60 to get it volume per second. So we divide by 60, and we end up with 50 centimeters cubed per second. So every second we are removing 50 centimeters cubed from our barrel. So that's the volume of this cylinder that we are looking for. So that means that the volume of our cylinder is pi r squared h must be equal to 50. That's going to be our volume per second, effectively. And we know the radius is going to be 10 centimeters. And the height is what we're looking for. And we know pi in this case we're taking is 3.14. And that's equal to 50. So we end up with 314 equal to 50. Divide both sides by 314. So the height is going to be equal to 0.1592 centimeters per second. Now there was no number of decimal places that we were required to give it to. So in the middle of a question, we'd put it to 4 decimal places, and then for a final answer, we would tend to give it to 2. So 0.16 centimeters per second would be the height that we are losing of water in our barrel every second. And that's what we need for our rates of flow, how quickly our liquids are flowing.